Prime factorization. So what we're going to look at here is first review what factors are and how prime factorization then works as we look at that. Factors are all the numbers that divide evenly into a number. So if you will recall, if we take a number like 24, for instance, and we think of all the different factors of 24, well, there's 1 times 24, 2 times 12 is 24, 3 times 8 is 24, 4 times 6 is 24, 5 does not go into 24, and then if we use 6 times 4 is 24, which is a duplicate. So if we kind of do this U here, this shows us all the factors of 24, and if I listed them, I'd have 1, 2, 3, 4, 6, 8, 12, and 24. So those are the regular factors of a number like 24. But now let's apply it to this, prime factorization. What if we're looking at just the prime factors of the number 24 and how we can factor that out? Prime numbers, as you might recall, are numbers, a number with only two factors, 1 and itself. And some examples right here, like 5 and 11. 5, only 1 times 5 equals 5. You can't get multiply anything else together to get 5. And the same with 11. 1 times 11, 1 and 11. Nothing else goes into 11. And this is kind of a list here of just the prime numbers from 2 basically through 100. Remember, 2 is the only even prime number. Every other even number is actually a composite number, which means it's made up of more than 2 factors. So 2 is the only even prime, and then you can go from there. So let's talk about prime factorization. So what if we went back to 24 again, and we talked about prime factors of 24? Okay, well, we find the prime factors, we're going to look for the numbers that are like the prime numbers. So we're actually going to use like a factor tree. So I'm going to pick any multiples that go into 24, kind of like 12 times 2. So I'm going to put 12 times 2, 12 and 2. Now I'm going to look, are either one of these numbers prime numbers, 12 or 2? Well, 2 actually is a prime number. It's the only even prime number, so I'm going to circle it, and I'm going to leave that number alone. But 12 is a composite number, which means you can multiply 2 other numbers together to get 12. Well, what can I multiply? A couple things if I want, but let's stay with this whole 2 thing, 2 times 6. Okay, 2 times 6. Are either of the numbers that I just multiplied prime numbers? 2 is a prime number. Is 6 a prime number? Nope, composite. What equals 6? 2 times 3 right over here. You're not going to want to use 1 like 1 times 6 because you'll keep having to multiply it out. So you're going to need to come up with numbers other than 1 that multiply into another composite number. I'm going to look here and see, do I have prime numbers? 2, as we talked about, is a prime number. Is 3 a prime number? Yes, 3 is a prime number. So now that I'm done and I don't have anything else to factor out, I've now found all of the prime factors of the number 24. So now I'm going to list them. So I'll list them like this. I've got 2 times 2 times 2 times 3. Because here's my 2 times 2 times 2 times 3. So if I multiplied together 2 times 2 times 2 times 3, I would get 24. Now, the shortened form with exponents of writing this goes like this. How many 2's do I have? 1, 2, 3. 2 to the third power times 3 is going to be my final answer, is the prime factorization of 24. 2 to the third power should get you 2 times 2, which is 4 times 2, which is 8. And 8 times 3 is 24. So this is what it'll look like when you get the prime factorization. Another example, what if we took a value like 64? So I'll start with this one, I'll write a little smaller. You guys can work ahead if you want, or you can practice it on your own. But I'm going to factor out 64. I'm going to think of anything that can go into 64. I'm going to do 8 times 8. So I'm going to say 8 times 8 is 64. And it doesn't matter if you think of something else. 32 times 2, for instance, would work, but I'm going to do 8 times 8. Do I have any prime numbers? No, I don't. 8 and 8 are both composite, so I'm going to have to factor both of these out. Got my factor tree going over here. What equals 8? I'm going to do 4 times 2, of course. So I'm going to do 4 times 2 here. Do I have any composites and primes? Should I have any primes? I guess the answer, yes I do. Prime numbers. 2 is a prime. 4 is not. So I could continue to factor this one out. What equals 4? 2 times 2. 2's are prime numbers. And then I'm going to do the same thing on this side, because to get 8 I can do my 4 times 2. There's my prime there. If I continue right here, this is 2 times 2. And these are my prime numbers. So all of them circled in blue are all of my prime numbers. So once I list them, I should get something like some space right over here. 2 times 2. I have 1, 2, 3, 4, 5, 6. 2 times 2 times 2 times 2 times 2 times 2. Now, once I do all of those right there, I can do this with exponents. How many 2 to the 6th power right here is the prime factorization of 64. 2, if I multiply it to the 6th power, would equal 24. So this is how you represent the prime factorization of a number. Remember, locating all of the primes and then multiplying them, putting them together basically in a multiplication expression, and then from there writing the exponent up at the top.